Very good morning, dear students. So, in the last session, we discussed about logarithmic differentiation. The important thing is how will you identify that when a question is given to apply logarithmic differentiation. It is when the function to be differentiated is given in base index form in such a way that both base and index are functions. So, what I mean is when you write x cube, when we write x cube, base is a function but power is not a function. This is, of course, this is in base index form, but here no need to apply logarithmic rule. But when it is given in x power some sin x, you see here base is a function, power is also a function. In all circumstances, when a power function is given, we will apply logarithmic rule of differentiation. Let us see some more problems solving here. We are going for some more problems. See. Let us find dy by dx. Here is a question like this. Find dy by dx if cos x whole to the power of y is equal to cos y whole to the power of x. Okay. So an expression is a relation is given. You have cos x to the power of y is equal to cos y to the power of x to find dy by dx. Now you analyze both sides, both LHS and RHS. You see they are in base index form. Base is a function, power is also a function. Base is a function, power is also a function. So in such case, in this case, we will apply what? Logarithmic differentiation. First of all, power rule of logarithm. So you see, we will write given this thing and we have this. Okay. So we have this one, cos x to the power of y is equal to cos y to the power of x. Apply log on both sides. Apply log on both sides. What you are getting is, see, logarithm of cos x to the power of y is equal to logarithm of cos y to the power of x, right? We apply log on both sides. Then here you apply the power rule of logarithm. Power rule of logarithm says log x power n is equal to n log x. The power comes in front of the log. Then what happens here? This implies this power comes in front. Okay, this comes here. What you are getting is y into log of cos x is equal to, same idea here. This power comes in front of log. You get x into log of cos y. So you write in such a way into. Now you see it is product of two functions on both sides. We are going to differentiate this function with respect to x on both sides. So we must apply what? Logarithmic rule of differentiation along with. So here it will come product rule as well as chain rule. See here log of cos x, here log of cos y. So chain rule will be applicable to here product rule. Now you apply product rule here. So first into y. First into derivative of second. Derivative of log 1 by. So it is 1 by cos x into derivative of cos x minus sin x is equal to plus. So here it is first into different derivative of second plus second into derivative of first. So it is log of cos x into derivative of y dy by dx. Okay. So that's the derivative of left side only is equal to, in the same way, differentiate the right side x into. So first into, you see, first into derivative of second. Here what you have to be more careful is, here the variable is y. So here everything comes there. Chain rule, okay, chain rule along with implicit differentiation. So here it is x into derivative of this 1 by cos y, derivative of cos y minus sin y. Because of y, you must write what? Dy by dx plus first into derivative of second, then second into derivative of first. So it is log of cos y into x. Derivative of x is 1. Let me remove something. All these things. Once again, up to this step, given this one, both are power functions. We are applying log on both sides. So apply log here. After applying log, you differentiate both sides with respect to x. So here, product rule along with the chain rule. Here, implicit rule again. Okay. That of log of cos y. Log of cos y. 1 by cos y, derivative of cos minus sin y, that of y dy by dx. Right. Now let me remove this some part. Okay, we will we have to, okay, this side. Oh, sorry. Right, let's do it. Now what we are going for is here is dy by dx. Okay. Now what we want to find is dy by dx. You can once let us collect all the terms in dy by dx. What are the terms in dy by dx? You can see here is a term in dy by dx, and one more term here. Okay. So what I am doing is I am collecting those terms in dy by dx. So it is dy by dx into the term here. What is it? Log of cos x. Log of cos x. Okay. Now the second term is to the right of the equation. Shift it to left side. So this minus comes here, becomes plus. What remains is dy by dx is taken here. What remains is x sin y by cos y. You know sin y cos is tan. So we will get x tan. Okay. Is equal to. So these two terms are clear. Now this and this term remains. So we are writing that term log of cos y. Log of cos y. This term is to be shifted to that side. So minus. So it will become plus now. What remains? You see sin y and cos tan y tan x. Y tan x. Now we are asked to find a dy by dx. Finally, last step is here. Therefore, let us conclude dy by dx is equal to that by this log of cos y plus y tan x whole divided by log of cos x plus x tan. So very minutely you have to go for each and every step. Okay, let's go for one more problem. The coming problem is asked many times in exams. So be careful. Here is given if some x power m into y power n is equal to x plus y whole to the power of m plus n, find dy by dx. Oh, so same problem is asked like to show that, to prove that dy by dx is equal to y by x when x power m, y power n is equal to x plus y power m plus n. Here the function given is, you see what the function given is this one. Okay, here is the function given. Each and every term is in base index form. But here base is a function, but indices, you see indices m and m plus n are not functions. They are simply they represent integers, right? So actually there is no need of logarithmic differentiation. But in this problem, using logarithmic differentiation will minimize the complexity of simplifying the problem. So what we are going for is we are going to use logarithmic differentiation. So we are starting from this one, x power m given, okay, given x power m, y power n is x plus y power m plus n. Applying log on both sides. So applying log on both sides, you see it is a log of x power m, y power n is equal to log of x plus y power m plus n. Now apply logarithm. This side directly becomes what? This side becomes, power comes in front, okay, m plus n log of x plus y, okay, that's it. What about the left side? Why I write the right side? This is directly of the form x power n. So n log x, okay, n plus n log of x plus y. Why I study the left side is, you see, here actually left side is a product of two functions. So logarithm of product is explained as sum of individual logarithms. Okay, log of xy is log x plus log y by the product rule of logarithm. Then how to rewrite this? You see, this will be rewrite as log x power m plus log y power n. Okay, log x power m plus log y power n. Now consider the first term, log x power m. M is the power there, so it will come in front of the log. This becomes m log x. Okay, plus. What about the second term? It is log y power m, that is n log y. So this is the easiness of applying logarithmic differentiation, applying logarithm in this way. Now we are going to differentiate. You differentiate both sides. You see what you are getting is Did you get this step? Let me explain once again. We have x power n, y power n is this one. Apply log on both sides. Log, right? Now you see here, this is logarithm of a product. Okay, logarithm of a product. Logarithm of a product is sum of individual logarithms. So this will be log x power n plus log y power n. So log x power n becomes m log x. Log y power n is n log y. Now you differentiate both sides. M is a constant. So m into derivative of log x 1 by x plus n into derivative of log y, implicit log. It is 1 by y into dy by dx is equal to m plus n is a constant. Okay, into derivative of log 1 by x plus y. Now you have to take care here into one more main term appear here. Derivative of log 1 by. Now derivative of both of these. Derivative of x 1 plus derivative of y dy by dx. Okay. Now as usual, what we are going to do, let us write one more step. This is m by x plus n by y dy by dx is equal to what this gives m plus n by x plus y into 1 plus dy by dx. Okay. Now we are going to collect the terms in dy by dx. Let us collect the terms in dy by dx. Let me cut up with you. Now you see, if you want to collect dy by dx, what are the terms in dy by dx? Here is a term in dy by dx, as well as here is a term in dy by dx. Okay, 2 terms. So collecting, let me shift to that side, or you take this side, let us take. So it is dy by dx into, okay, dy by dx into, here the term is n by y minus, y minus, here it is, m plus, here it is plus. So come to this side, it becomes minus, m plus n divided by x plus y equal to, what are the terms to right side? Here is a term, right? This term will stay in the right side itself. M plus n by x plus y minus this term go there, so it is m by x, right? It's m by x. Yes, let us simplify. It is dy by dx into cross multiplying. See, it is nx plus ny minus what you are getting, my minus ny divided by y into x plus y. Okay, equal to right side cross multiply mx plus nx minus n minus mx minus my divided by this x into x plus 1. Right. Let's cut some points. Now simplify. Where we are getting is dy by dx into, okay, simplify this. You see here ny cancels. Okay. What here mx cancels. This x plus y both results. Now write remaining. What remains is dy by dx. Here nx minus my divided by y is equal to, again, nx minus my divided by x. You see, numerators are again equal. Nx minus my again cancels. Finally, we are at the answer. Therefore, dy by dx is equal to cross multiply this y go to the numerator y by x. So, such an important problem in logarithmic differentiation. See the last steps. How we get that? See the last steps. You see n by y minus this one, cross multiply, you have nx plus ny minus my minus ny by y into x plus y. Right side as well. Cancel the corresponding terms and simplifying, you are easily at the answer.